Hello, Geometry Advanced students. So today we're going to continue with with chapter 10 and move on to talk about what it means for two chords to be congruent. Okay, so if I look at this picture on the left, let's try this again. There we go. So if the two chords are the same distance from the center of a circle, what can we conclude? Okay, so if I'm looking at the picture, again, I know that GE and GF are congruent because, again, it's got the tick marks to show that. So what does that mean? Okay, well, if I think about it, we're in the same circle, right? So we have, like, radii I could draw in from DG and AG when all radii of a circle are congruent. So if I think about it, what's true about those two triangles? This triangle AEG and this one DFG. Hopefully you're going to make the conclusion that they are congruent. We've got hypotenuse leg going on. And if the triangles are congruent, all of the corresponding parts are congruent. So for example, segment DF and segment AE would be congruent by CPCTC. Okay, so what I was saying was if we thought about yesterday's lesson, we had if a segment that goes to the center, if it's perpendicular to the chord, it bisects the chord. So we know that DF and CF are congruent as well as AE and BE are congruent. So different conclusions we could make would be, if you wanted to say, you could say segment DF is congruent to segment AE. That would be acceptable. Another conclusion, since we're talking about if two chords are the same distance from the center, then we can conclude the chords themselves are congruent. So like DC and AE. So segment DC would be congruent to segment AB. Okay. So again, if two chords are the same distance from the center, then our conclusion is going to be they're congruent. And that is going to lead us into our first theorem here. So it says if two chords of a circle are equidistant from the center, or the same distance from the center, then they are congruent. Again, that's based on our conclusion we just looked at. We actually could have written the proof for that one. So if I look at this picture, it says in circle P, segment PQ is congruent to segment PR. So that is telling you that the chords AB and CD are the same distance from the center. So if AB is 6x plus 12, and CD is 4 minus 4x, and we're going to find AB. So again, AB and CD are going to be congruent because, again, they are the same distance from the center. Okay, so we're going to set them equal to each other. So we're going to say 6x plus 12 is equal to 4 minus 4x. So if I'm going to solve for x, I would probably add 4x to both sides. So we're going to have 10x equals, and then if I subtract 12 from each side, 4 minus 12 is negative 8. So to solve for x, if I divide both sides by 10, x is going to be negative 8/10, which was going to reduce to negative 4/5. Okay, so again, if the chords are the same distance from the center, then they are going to be congruent. Okay, so continuing on with the notes. Let's do another example. If I could get this to work here. There we go. Okay, so in this one, if PB is x plus 4 and CD is 3x minus 2 and OP and OQ are both 48, we want to find AB and then the radius of the circle. So in this picture here, if OQ and OP are congruent, if they're equal to 48, it doesn't matter for the first part. Basically, for helping us find AB, we're going to use the fact that the chords are the same distance from the center, so they're congruent. So if PB is x plus 4, and that means that AP is also x plus 4, so that's going to imply that the whole segment AB is 2x plus 8. And again, it tells us that segment CD is 3x minus 2. So again, AB and CD have to be the same length because, again, they're the same distance from the center. So we're going to set them equal to each other. So we're going to say 2x plus 8 equals 3x minus 2. So if we're going to solve for x, the first thing I would do would be to subtract 2x from each side. So we're going to have x equals, And then to continue to solve for x, I would add 2 to both sides. So 8 plus 2 is 10. Now that is not my final answer for part A. That just tells me that x is 10. Well, we said that AB was 2x plus 8. So 2 times 10 is 20, and 20 plus 8 is 28. So the length of AB is 28. For part B, we want to find the radius of the circle. So if I draw in the radius, again, maybe I'm looking at one of these right triangles here. Okay, and maybe I'll draw it off to the side here so it's not so messy. So it told us that, here's OPA to make it easier. So if AB is 28, that means that AP is going to be 14. And if PO, it tells us in the problem, is 48, and again, I want to find the radius of the circle. So thinking about, again, your Pythagorean triples, because they keep showing up, 14 and 48 are not a triple itself, but they are divisible by 2. So that would be 7, 24, and that triple goes 7, 24, 25. So to find the radius, I would double that, so 25 times 2 is 50. So again, those triples, those special right triangles are going to continue to keep showing up. Okay, continuing on here, we've got a theorem we're going to talk about yet. So it says if 2 chords of a circle are congruent, then they are equidistant from the center. So this is just going back in the other direction from the first theorem we talked about today. So again, it's biconditional because it works in both directions. So if 2 chords of a circle are congruent, then they are equidistant from the center. So if we're given that we have circle O and that AB and CD are congruent, so the chords are congruent, and we also need to be given that OE is perpendicular to AB and that OF is perpendicular to CD, then we can conclude that, again, they're the same distance from the center. So in this picture, it would be segment OE congruent to segment OF. So again, if the chords themselves are congruent, and again, the distance and OE and AB are perpendicular, as well as OF and CD, then again, they're the same distance from the center. We could prove this with congruent triangles and a CP/CTC step if we were writing a proof. So for your assignment today in your textbook, you have page 448, numbers 1, 2, 6, 7, 11, 12, and 13. And as always, if you have questions, please let me know.